This project will be an analog to digital converter using state machines and the state machine design tables and Quartus. Eventually, a waveform will be modeled in ModelSim, and the different states can be seen in the waveforms within ModelSim. So the first process in all of your Quartus projects are to create the new project file. And then once you create the project file, come into your main diagram here and go to the new and state machine file. Once you create the state machine file, this screen will be blank, and you can start using the design tables to create your different state machine and state machine scenarios. To use the state machine design tables, you click on the state machine wizard right here. And then in the case of a new project file, you'd create a new state machine diagram right here. The first step in this process is set up your general tab. Usually you can leave this the same as synchronous, and also for this model we can leave it the same as well. And then based off the state machine diagram in the textbook right here, you'll have your inputs, which is the first tab in the design table. And in this case, our inputs will be the T, which is the trigger, and it distinguishes when to go to the next state, and DR, which is the direction. It triggers which direction to transfer, which state to go to. These inputs can be seen right here in the input tab of the design table. And to add a new input, you can just click new and then type in whatever design or whatever input you want. You can leave the directions or the control signal as no, because the only control signal that matters is the clock and reset, and those will be automatically put in. Your outputs in this diagram are SC and OE, and those can be seen also in the state machine diagram right here. So the SC stands for the start conversion, and that's what will really matter in this diagram. Again, to add a new output, all you have to do is click the new tab and then type in whatever you want your output to be named, and then you can leave the rest of this the same. It doesn't matter. For the analog to digital converter, we're going to have 4 states, and in the diagram within the book, these states are known as idle, start, waiting, and read. I named them S0 through S3 just for simplicity's sake. But then, so one thing to note in the states tab is you want your 0 or idle state to be a reset. So when it gets back, when you complete the cycle, it resets itself. All the other inputs or all the other states can be left as no reset. And then similar to the other tabs, to add a new one, all you have to do is double click the new tab and name it whatever you want. The next tab in the design table is the transitions, and this is where you plug in what you want to happen within your state diagram. The transitions are determined based off this diagram in the book, and to determine what's going to happen, you look at what state the T input and the DR input are. The states are whether it's high or low. For example, in this state, to go from 0 to 1 or idle to start, T has to be high or 1, and the direction control doesn't matter, and that's usually marked by an X. So in the case of this diagram, or the analog to digital converter state machine, these are the different transitions that are going to be required to make the state machine operate correctly. So if you look at the diagram in the book, the first transition is the idle is just repeating itself. And this happens when T is low and DR, it doesn't matter, so you don't have to worry about it. This can be seen in the design table right here. To go from state 0 to state 0 or idle to idle, the transition is low. And to mark the transition as low, the little tilde right here is applied. If the tilde is not there, it means it's high or T equals 1. And then continuing on, to go from state 0 to 1, T equals 1. And that can be seen right here. And then 1 to 2, it doesn't matter what happens. It doesn't matter if T is high or low, and it doesn't matter if DR is high or low. And so you don't have to do any transition there. That can be seen in the book here. It doesn't matter, and it's marked by an X. And then state 2 to state 2, that will repeat itself, and that's when DR is low. T does not matter. State 2 to 3 is DR, which is, your transitions are done through your inputs. So when DR is high or 1, state 2 will go to state 3. And then state 3 will go back to 0 when T and DR don't matter. So you can leave that blank. Your actions tab are what happens to the outputs within the state. So when you get to, for example, state 0 here, your output SC, or your start condition, is 0. And then when you go to state 1, it's 1. State 2, 0. State 3, 0. And then your OE input or output that you applied earlier, in the states, it's the same situation. State 0 is 0, 1 is 0, 2 is 0, 3 is 1. Once your design table is complete, you can click OK, and you will be given this diagram. This diagram represents the transitions and states that you applied earlier. For example, state 0 right here will repeat itself when T is low. It'll go to state 1 when T is high. Once you have your state machine diagram like this, you can generate a Vhdl code by clicking Generate HDL and selecting Vhdl. Once you have your Vhdl code created, you want to open up ModelSim right here, and this page will generally be blank. What you want to do is you want to create a new project by going to File, New, Project. File, New, Project. And this is where you name your project in ModelSim. You want to put the project location in the same folder as your project, and generally put it under your work folder. You can leave the rest of this table the same. Once you get to this will automatically pop up, and once you get to it, you can add existing file and just browse for it. This is where you'll be adding your Vhdl code that you generated from the state machine diagram. Once you add the file, you can click OK, and it should pop up right here. The status will be unknown and represented by this little blue check mark right here. And then once that's there, you can compile the project. And if everything compiles correctly, you'll get the green check mark. Once you get the green check mark, you can simulate by going to the Simulate tab and starting the simulation. The Start Simulation dialog box will pop up, and you want to go under the Work folder by clicking the plus mark and selecting the Vhdl code you had created from the state diagram. if this Objects tab doesn't show up, the Objects tab is where you can see the different inputs and outputs of your state diagram, and that's automatically generated for you. If that doesn't pop up, you can come under View and select Objects, and it'll automatically pop up. What you want to do is you want to select your clock, your reset, and all of the inputs. In this case, it's the T and DR, as well as the outputs and the states. Once all those are highlighted, you can right-click and add them to the wave. You can come down here and you can see the wave is now populated with your different inputs, outputs, clocks, resets, and states. And this is where you can generate the waveform to make sure your state diagram is working as it should. So the first step is you want to apply the values to your clock. And to do that, you can right-click on the clock and go to clock, and you want it to be on a falling edge. So just click falling under the first edge dialog box. And then for this simulation, you can just do a force every 10 nanoseconds will be fine. And then you want your reset to be high, so you come over here, right click, and you force it to be high for the initial state. And then in the state diagram, the initial state right here is T is low and DR doesn't matter. So we will take those input values and apply them to the inputs. So we keep T is low and DR doesn't matter, so we don't have to touch it. And you don't have to mess with the outputs because those will be automatically generated. So once you apply those changes to your inputs, you can run the wave and you see state 0, or the idle, is now displayed. To go to state 1, the reset is set back to low, or 0. Your T is made high, and DR does not matter, so we don't have to change that. So we come back to the wave, force T high. We can leave DR the same, and we should get state 1. Yep, state 1. To go to state 2, T is left low. Let's look at the die. T is set as lower, does not matter, and DR is set as lower, does not matter. So we will set T as low. And then run it. And we get state 2. The next state is state 3. And to do state 3, we look at the diagram. We set T is lower, does not matter, and DR is 1. So we will leave TR, or T is low, and DR, we will force that high. And state 3 appears. Now to get back to state 0, we look at the diagram. And we can see that it does not matter what the inputs are, so we can just leave them as low. Put DR as low. And you can run the simulation, and you can see it goes back to state 0. So once you have your state machine waveform completed, you just want to make sure you have the inputs corresponding to the actual diagram itself. And once you double check that, you should be good to go.